Welcome to the Risk Assessment and Safety Management, or RASM, webinar. This presentation will provide you with a detailed look at how to implement the RASM model as part of your overall risk management training. My name is Rick Curtis. My pronouns are he, him, and his. I've been the director of the Princeton University Outdoor Action Program for the past 38 years. I'm the author of the Backpacker's Field Manual, which is used as a textbook in outdoor recreation programs across the country. I'm also the founder of OutdoorEd.com, the premier resource for outdoor education professionals. And I'm the founder of IncidentAnalytix, a cloud-based software program for incident and close call tracking and real-time data analytics. Today's workshop is designed to prepare you to teach this same workshop to your staff. The workshop content typically takes about 1 to 2 hours. Storytelling is a really important part of this training, and teaching through telling your staff about real incidents that have happened in your program is an essential part of the educational experience. Presenting this workshop with your own stories will also increase the length. With these two stated goals, I won't do a deep dive into the RASM model at the program administration level. There's a detailed article on that at www.outdoored.com that provides that level of material. Just search for RASM. During most of the workshop, I'll present it as if I'm teaching it to one of my groups. When I need to step out of presenter mode to give you some background instructions or insight, I'll say offstage, and when I go back into presenting, I'll say presenting. So here we go. Risk management is not just the caution sign on the wet floor. You need to think about risk management as part of your overall program structure. And it's something that should be implemented from field staff all the way to the board level. Risk management is everybody's job. And so providing everyone in your organization with a model that helps them understand how risk happens also helps them understand what role they have within their particular job portfolio for how to assist you in managing risk. The learning objectives for today's webinar is to provide you with a complete training module for your staff. We'll help you identify the principal causal factors in accidents and near misses, explore how the RASM model provides for managing risk that incorporates those causal factors, identify how you assess and manage risk before an event, and then also use the model to evaluate risk and mitigate it in real time in the field. What is an incident? Offstage. This is a good example of where I would ask the audience how they would define what an incident is, and then come back to it after we get interaction from folks in the audience. On stage. So how would you define an incident? It's an event with some negative outcome. That could be an injury and illness, it could be property damage. Variety of different things might fall into that negative outcome. The other thing that you need to be aware of are close calls, near misses. So those are things where there was not a negative outcome, but there potentially could have been. And the degree to which you could have had something happen says a lot about the potential risk level. So let's take a look at types of incidents. There are a whole variety of things that fall into the definition of what could be an incident. Injuries, illness, motivational behavioral issues, psychological issues, bias incidents, crime, harassment, inappropriate or criminal sexual contact, property damage, and the list goes on. Whatever your particular organization is, one of the things that you need to understand is what is the framework that you're operating in? What are the types of incidents that either have happened or could happen? Understanding that ahead of time is what helps you prepare for dealing with the potential risk that you might experience. So if we define something that has a negative outcome, the potential for injury, loss, illness, we're going to call that negative R. So in essence, that possibility for some negative consequence is the negative R. Now, if we have negative R, what would be the corollary to that? And the answer is, of course, positive R. Positive R is the reward. That's the potential for gain, for growth and development. So we need to be aware of both the negative R and the positive R in the programs that we run. Another way to think of this is balancing the negative R risk with the positive R reward. So whatever program you're operating, there is always a balance between those two things. And it's important that there not be a significant imbalance in risk and reward. We should be taking risks that are at a level appropriate to the rewards that those risks offer. If we have really, really high risk for a really, really low reward, then we have to ask ethically, are we doing the right thing for our customers and our clients? So in any situation, we need to look at our client base, what their needs are, what our program is, and make decisions about how to manage that risk-reward balance. Risk is, for all of our programs, inherent. I'm particularly talking about outdoor adventure activities, and we know that negative R exists in those activities. It exists in sports. It exists in many, many of the things that we do. So we need to recognize that it is just part of the landscape. Also, we need to understand that it's expected. It can occur at any time, and we need to be prepared to deal with it when it happens. And finally, it's important to understand that negative R and positive R are essential parts of our program. When we think about, in my case, outdoor education, I recognize that placing people in challenging situations increases their risk. And it's also those challenging situations that really propels the personal growth that happens to students. So we know that there will be some negative R in that environment. And in fact, that's what creates some of the positive R. And I need to balance, all of us need to balance those two. In a program that I'm running for college students, I'll probably need to accept a fairly small negative R for the positive R that's appropriate. If I'm dealing with a different population, for example, therapeutic adventure program, where the students who are involved in that program, the clients or participants, are dealing with drug addiction or other serious psychological or behavioral issues, they already have a really big negative R that they're living with every day. The positive R of participating in this program is the ability to get off drugs, to make significant changes in their lives. And so that's a really, really big reward. And it may be either appropriate and in some cases necessary to have a higher level of negative R to achieve those positive goals. So they're still in relative balance. What's also important in this is for you to determine what the appropriate level of negative R is for your program based on the positive R that you're dealing with. So how do we manage risk? The overall RASM model takes into account a number of different things. One is the negative causation factors, or hazards. Hazards have been used in lots of other risk management models, and that's a key foundation of all risk management. There's another piece, because in addition to the hazards that increase the risk level, there are also safety factors which can dynamically interact with the hazards to reduce the risk level. So we also have to look at what our mitigating factors are in determining our overall level of risk. The RASM model says that managing risk is achieved by either reducing the hazard factors and or by adding safety factor. And that's the basic fundamentals of the model. Let's take a look at the accident iceberg, offstage. At this point, I ask people to think about, what do you know about an iceberg? And the big point that we want to get people to take away from is that most of an iceberg is below the surface. You don't see it. So using that as a metaphor, we can illustrate an important research point about incidents and how they happen on stage. The accident iceberg. This is a study done by Bird and Germain in the late 80s and early 90s. And it really looked at industrial accidents, but their data has been applied to lots of accidents generally. They were looking, for example, at how many people were injured on a really big factory floor, and they were looking at tens of thousands of workers. For every single serious or major injury that they discovered, they found that there would be 10 cases of minor injury, 30 cases of property damage, and then 600 near misses or close calls, things that happened where there wasn't actually a negative consequence. The big takeaway from this is to think about what the most important data point is. Offstage. At this point, I do some questioning of the audience to ask them to sort of think about what the best data points are presenting. I'll give an example from the outdoor program that I run. It's been around for 45 years, and over that time, we've run thousands of backpacking trips. With all the trips that have been out, think about all the backpacking stoves that have been lit over those years. How many stoves have flared up and burned someone in the face? How many times do you think that's happened? The answer is 1. How many times do you think stoves have flared up and people have jumped out of the way and not been injured? The answer to that is, I don't know exactly, but it's in the hundreds or thousands. So which data point is actually the most useful for predicting what the risk level is of using a backpacking stove? And the answer is the close calls. So that's one of the key takeaways I want everybody to get from this workshop. It's really critical to track your incidents, and it's also really essential to track your close calls. If you were to only look at that one single incident event, your assessment, what you would draw from that is that working with backpacking stoves isn't particularly hazardous. We don't need to spend a lot of time worrying about this or training our staff, etc. If you look at the number of close calls, that gives you a much, much better picture of how hazardous a backpacking stove can be. This is a really important concept that we want our students to understand. The other thing is also the psychological concept behind close calls and near misses. We all have them. And one of the things that happens when you're in a situation that is actually high risk and you have a close call and nothing bad happens, it can tend to have a desensitizing effect. And the impact of that is we don't actually recognize how hazardous the situation was. And so we're often willing to put ourselves right back in that same situation because we've said, I've done it before, there were no problems, so I really don't have anything to worry about. So again, one of the key things about having people think about their close calls and analyze them themselves is so that they get an understanding of, wow, what was my actual risk level in that instance? That's going to help them make better decisions. If they can assess the risk level, then they can make good judgments about whether it's too risky to keep going or whether they need to make some changes. I talked about risk level, and let's define that a little bit more. Risk levels are increasing levels of risk, and therefore the higher the risk level, the greater the potential for a negative outcome. You could have a really high risk level and no negative outcome. That's a close call. In this case, we're going to just look at a general sort of ascending scale on all of our graphics of 1 to 5. Those are not the actual numbers that are useful to use, but in order to be able to see it in graphics, we're just going to illustrate it in that way. And as I mentioned before, that risk level is caused by the interplay between the hazard factors and the safety factors. That's what moves the needle of the risk level back and forth. And there's no such thing as an overall risk level of 0. Offstage. I always ask this as a question first. Is there such a thing as a risk level of 0? And let the audience answer. Typically, they get it right. If they don't, it's your opportunity to say that accidents can happen at any time. They are to be expected. And so there isn't a risk level of 0. There's always some risk, even though it's very low. Presenting. Here's the important risk formula that you need to understand. The level of risk is the probability that something's going to happen times the severity if it does. That defines the number that is the risk level. Another way to say that is, how likely is it to happen and how bad would it be if it does? This is a critical concept that you want all of your participants to understand. So let's take a look at that in a graphic context. If we map this out with probability along the left axis and severity of consequences along the bottom axis, and if we take a really simple metric of low, medium, and high for each of those, what you'll see is that when things are in the green zone, then our level of risk is pretty low, pretty manageable. As it starts to move into that yellow zone, now we're moving into some potential either greater severity or greater likelihood. And I talk to my students about that dashed line and say, when you get to that dashed line, you need to be sort of paying attention and starting to think about what your intervention strategies can be. Obviously, when you get into that red zone, now you're at some significant risk for a negative consequence. And you should be really amping up what you need to be doing to intervene. We can make this more granular by going and taking a look at a risk level calculator. Let's take a look at our sample risk level calculator. So this is a simple Excel spreadsheet. And what I've done is basically create some spinners down here along the bottom axis and along the side axis. And so across the bottom we have our severity level, and across the left axis we have probability. And we have 3 categories: low, moderate, and high. And within each one, there is a range. So low starts with 1 and then goes to 2 and 3. Moderate goes 4, 5, and 6. And high goes 7, 8, and 9. And that's true along both axes. So what you can see here right now, if we look in the leftmost bottom corner, what we're doing is we're multiplying 1 of probability and 1 of severity, and we get a 1 of our risk level. And if we go up in probability, we're multiplying 4 times 1 and 4 and 7 times 1. And so you can see how all these grid numbers are calculated. So what we'll do here is just start to increase the severity level. So I'm going to go down here to the spinner, and if we click and move it up to a 2, you can see what happens to the numbers above. And if we take it up to a 3, and now we're going to go over to the moderate. It's at 4. We're going to take it up to 5. And now we're going to take it up to 6. And we're going to go to the high level of severity. And we're going to take it to from a 7 to an 8 and up to a 9. So that's just changing the severity level. Now let's go increase the probability level. We're going to go from a 1 to a 2. And up to a 3. Then we're going to go to moderate. We're going to go from a 4 to a 5, and from a 5 to a 6. And now we'll go up to high probability from a 7 to an 8, and from an 8 to a 9. You can see now that we have a range that extending now from 9 at the low to 81 at the very top. This gives you just a kind of good general tool to think about how probability and severity interact with each other and how those scores can change, how those numbers can go from 1 at the very, very lowest all the way up to 81. That's a big spread. So this is a useful little Excel tool that staff can play around with, change some of the, the combinations of severity and probability and see what those numbers are. Going back to our sort of basic scoring system, we can think of this as a green light, yellow light, and red light. And if we flip this over as part of our risk level, what we get is just this horizontal column, and the risk level, that black bar towards the left side, moving up or down as the risk level changes. That's the sort of basic concept I want you to think about of going from low to high risk. And we'll look how the model implements this as we go. The best way to really think about how risk plays out in a situation is to take a look at a real accident situation. So we're going to take a look at a scene from Tom Hanks in the movie Castaway. This is one of my favorite movies because it gives such an excellent picture of risk management and the RASM model in action. If you're not familiar with the movie, the basic setup is that Tom Hanks works for Federal Express, and he's flying across the Pacific in a FedEx cargo plane with a crew of 4 or 5 to do a job over in Asia. They get caught in a bad storm in the middle of the night, blown way off course, their radio goes down, and the plane ends up crashing into the ocean, and Tom Hanks is the only survivor. He wakes up on this desert island, and you're going to see a scene where he wakes up in the middle of the night, and he goes down to go to the bathroom, and he looks off into the distance on the horizon, and he sees the blinking light of a ship. He realizes that there's somebody out there that might be able to rescue him. What I want you to do is watch what happens, and you'll see an accident unfold. So your job is to look at all the things that are happening, all the different causal factors, the hazards that are in this situation that are adding into the picture and creating this high level of risk. Now we've seen what happened to Tom Hanks. So what were the causal factors? Offstage. At this point, using either a blackboard or a whiteboard, I asked the audience to brainstorm what they saw and asked them to come up with the causal factors. And I write them up on the board and I place them into 3 columns, just as they call them out. And I'll categorize them for you, and you'll see the categories as we go through the next slides. So what they're doing, I won't label the categories, but as we go into the situation, I'll build the categories out for them, and then they'll have built the first part of the RASM model. Presenting. What were the causal factors? Let's take a look at the potential hazard factors that led up to this incident. So one is that there were equipment-related hazards. Secondly, there were some environmental hazards. And finally, there were human factor or people hazards. These are the 3 main types of hazards that can take place and add to and create a higher risk level. So in the case of Tom Hanks and his accident, first we have his raft. It's really inadequate. It's underinflated. It's not appropriate for the situation. He's got the world's smallest paddle. He also has no food or water. In terms of environmental hazards, we have the coral reef, which was the actual proximal cause of his incident. That's what he sliced his leg open with. And we have the huge waves. And amongst other things, in terms of the people hazards, he didn't really have a plan. He was indecisive at times. And there was a lot of fear and anxiety. And there were lots of other human factor hazards as well. This starts to give you a picture of how accidents happen. If you think of each of these hazard factors, each of these hazards as a ball, it has a certain amount of mass and weight. And so the more of these balls we put on the left side of this scale, the more hazard factors there are, the hazard balls in the equipment or the environment or the people side, the more it pushes the risk level to the right. Now, just having a lot of hazard balls doesn't mean we're going to have an accident. Here's a good example. Let's imagine that I'm Tom Hanks, and instead of landing on the coral reef, I land 6 inches to the right of the coral reef, and I don't hit my leg at all. What would you call that? Right, a close call and near miss. And what's the risk level between the actual leg injury and the near miss? Right, there is no difference. The risk level is exactly the same. One had a negative consequence and the other didn't. But all the factors that led up to that and created that risk level are exactly the same. And that's one of the key points that you want people to take out of understanding this model. Now, spend a little bit of time and think about what hazard factors are. Offstage. Depending on your particular environment, the type of program that you work with, this is a slide to sort of customize that fits into your particular context. I use this as a time to have the audience brainstorm about environmental hazards, equipment-related hazards, and human factor hazards. And think about the types of things that might fall into those categories. In my context, I'm going to use outdoor things, but you might have some different things in your context that make more sense to your audience. On stage. So if we think about an environment, it's really important to think about what are some of the potential environmental hazards that might be out there. So here are just some of them. High water, high temperatures, lightning. Let's think about equipment. What are some of the hazards that happen in terms of equipment-related things? The 2 big things are, one, that the gear or equipment that somebody has is not appropriate for the particular situation or setting. It's not the right gear. And the other big issue with gear is that there's something wrong with it. It's broken. It's not functioning properly. So those are the two major things that are hazards associated with equipment. And finally, we have people. And people is really a very complex issue. And there's some extra slides in the appendices that sort of go through people. But with people, you want to think about your clients and participants. You want to think of your staff and your leaders. You want to think of the entire group. You want to think of the entire organization. There are all sorts of things that fall into that people category. So when we think about people hazards, one of the things that we tend to think of is things like medical conditions, physical fitness. Those are things that we want to know about the people on our trips because they might have direct impact on somebody's risk level. We want to think about things like fatigue and how that can have an impact. Group dynamics issues like poor communication and listening skills, those can also be significant people hazards. And the other one that's worth talking about is fear and anxiety. Offstage. I think it's really good at this point or at some point during your workshop, is to talk specifically about fear and anxiety. One of the things that we are all comfortable talking about as educators is the notion of learning zones, the comfort zone, the learning zone, and the panic zone. Many of you are familiar with that concept. And we know educationally that the learning zone, having people step outside of their comfort zone into a place where there's a certain level of discomfort, is actually the most productive learning environment for the brain. And we also know that when people move from that learning zone into their panic zone, that's a terrible learning environment to be in, and it has huge impacts on people's judgment, their physical performance, all sorts of things. So this is a really good opportunity to talk about an example from your program where there's been fear and anxiety, and suddenly that fear and anxiety has caused a significant risk level. As soon as somebody steps from their learning zone into their panic zone, their risk level skyrockets. On stage. Fear and anxiety. Here's an example. There was one of our backpacking trips was in a section of the Catskills on a place called Slide Mountain. And Slide Mountain has a rock slab. It's about 15 or 20 feet, and it's pitched at about a 30-degree angle. And it's kind of an all-fours scramble up to the top. The group is climbing up, and everybody was going. This was an outdoor orientation trip. The leader said, "Oh, everybody up you go." And one participant was kind of hanging back, and they were the last person to go. They started and got partway up and panicked and let go of the rock and slid down the rock face. Luckily, the leader was sort of down below and caught them under the armpits and kept them from, sort of broke their fall, kept them from injuring themselves. But at that point, the person said, "I'm afraid of heights." That person had gotten partway up and had gone right into their panic zone. And when people do that, judgment, all sorts of things just go away. You stop operating at the cerebrum of your brain and you drop into the reptilian part of your brain. And so you do things that actually don't make any sense, like letting go of the rock. And so that's an excellent example of how the risk level for somebody who's in their panic zone can skyrocket. I've been in situations where I know of people who were belaying for the first time, and they got really scared as a belayer, and they let go of the rope. Now, we know that's a totally nonsensical thing to do, but somebody in their panic zone is not thinking clearly. It's a really key point to bring up and recognize that you might have 9 people in your group who are all doing really well and operating in their learning zone, and their risk level is really manageable. And that one person who suddenly steps into the panic zone skyrockets up into their risk level. Things like communication, things that help with the group dynamics for people to be able to communicate when they're uncomfortable, things like a full value contract, challenge by choice. These are a lot of things that are kind of an integral part of outdoor education philosophy, but are also really useful across the boards in other kinds of contexts because they give you a platform to understand when somebody is moving into that space and for them to have the space to say, hey, this is not comfortable for me. And that's a critical risk management tool. So I always spend a little bit of time talking about fear and anxiety because it can be such a big hazard ball. So I talked about big hazard balls, and so that's another key concept. How big are the hazards? As I said, if we think of these hazards as having a certain size and weight, so the greater the mass, the greater the potential impact of that hazard is. It's also important to recognize that a particular hazard might have multiple impacts or negative consequences. And so when you're sort of calculating the total impact of that hazard, then you need to actually add those scores up. Let's say the probability of A happening because of condition X, hazard X. If we take the probability of A happening times the severity of A, but also B can happen because of X. So we take the probability of B times the severity of B and we add those together. The example is high altitude. One of the things that high altitude does is it can lead to pulmonary edema and also to cerebral edema. Each of those have their own probability and severity. But if we want to say what's the overall risk of being at high altitude, we also have to add those two together. And that's going to give us sort of a total score. So if you think back to our risk calculator, you'll understand how we might calculate a particular score for one and for the other, and then add them together. Let's take a look at a particular example of a hazard ball and think about how that plays out in the RASM model. The hazard impact. Let's look at air temperature, and we're going to think about this in the context of sports. The potential consequences of high temperature combined with significant physical activity. One is dehydration, another is heat exhaustion, and the third and the most serious is heat stroke. Let's imagine that we're dealing with a sports team. I'm going to use the example of football in 80-degree temperature. So it's end of summer, it's early season practice. Dehydration is a possibility at 80 degrees. The probability is actually fairly low, and the severity is relatively low. So if we go ahead and calculate those scores and multiply them together, we're going to get kind of a low risk. Okay, we're in that green zone. Heat exhaustion, the probability is still relatively low on our risk calculator. The severity is moderate because that's a more significant medical issue. But overall, even though the score is higher, it's still kind of in the low risk green zone. Heat stroke, the probability is still low, but the severity would be high if it did happen. So although we're still in the kind of low risk, we're moving up into that sort of yellow zone. If we think about the overall risk, we can sort of see that as a risk level of 15. So although there are some risks associated with these different heat illness related issues at 80 degrees Fahrenheit, it's not a really, really big danger zone. So it's not necessarily something that we have huge concerns about. Let's change the temperature. Let's imagine that it's up now 100 degrees Fahrenheit or 38 degrees C. Okay? Dehydration. The probability of that at 100 degrees is moderate, and the severity is moderate. So now we have a moderate risk level of 16. We're in the yellow zone. Heat exhaustion, the probability is moderate. The severity is high, so we're also at a moderate risk, higher up in the yellow zone. And finally, heat stroke, the probability is moderate, but our severity is quite high. So now we're at a high risk. Because all these three things could happen, the overall risk or weight of that air temperature ball is a combination of 16 plus 35 plus 45 for that 96. When we think about exercising and doing a sports camp or a clinic at 100 degrees Fahrenheit, this is a really big hazard ball. So when we go back to sort of looking at the basic RASM model, we can think of what's the size of this ball at 80 degrees, 27 degrees C. It's not really, really big. But at 100 degrees, it's a really big ball. And so we need to be sort of thinking about how we manage this risk. The other thing, if we go back to thinking about the Tom Hanks situation, is also to recognize that air temperature is not the only factor that's happening in this particular situation. I laid it out as football. And so we're thinking about equipment-related factors, right? Somebody's wearing a heavy uniform with pads. They're wearing a helmet, so that helmet is reducing the ability to lose heat through the head. Maybe there isn't food and water readily available on the field. We've got the air temperature, but also what's the relative humidity? Obviously, we know that if the relative humidity is high, that decreases the effectiveness of sweating for evaporative cooling. So it's going to be harder for the person to sort of cool down. Let's look at some of the people factors, the human factor hazards. What if this person is dehydrated? What if it's an inexperienced person on the team? It's their sort of first season. They're a first-year student, and there's some fear and anxiety. They don't feel comfortable going to the coach on day one and saying, Coach, I feel headachy, I feel a little weak, I need to sit this one out. So you can start to see how all these other factors, right, are adding in to that air temperature, and they're jacking the risk level up bit by bit by bit. So it isn't just the air temperature. It's potentially all these other things that might be happening in this situation that's driving that risk level to the right. Let's think about what we can do to manage that situation. So if we can remove some of these hazards, if we can get rid of the really heavy uniform, if people don't need to be wearing their helmets or can take them off in between plays, etc., if there is adequate food and water available, so we can remove potentially some of those hazards. Now, what about the air temperature and the humidity? Well, probably there's nothing we can do about that, but we can make sure that people show up to practice already hydrated and that that's something that they know is part of their prep before they even get to the field. The inexperienced thing, what can we do as we bring people onto this team to help them feel like they understand that safety is a critical part of everybody's responsibility on the team, both good self-care and that other people need to be watching for you. And also the fear and anxiety thing. How can we reduce that, okay, so that we minimize the impact that that might have? So when we talk about managing risk level, how do you reduce that risk level? And we just saw an example of that. The first thing you want to do is to remove all the hazards that you can. Obviously, that begins with identifying what those hazards are. You need to be able to scope them out and understand what the hazards are in your situation. And then proactively yank all the hazard balls you can out of the picture. And then what you want to do is reassess and say, okay, we've pulled all those things out. Now what's our risk level? What if that's not enough? You've done everything you can about the hazards, but it's still not enough. And that's what we talked about at the very beginning. You need to add safety factors in. If removing the hazards doesn't do it, and in some cases there are hazards like the air temperature and the humidity that you cannot make go away, then you need to have some safety factors to bring into the situation. And as you can imagine, there are equipment-related safety factors, there are environmental-related safety factors, and there are people-related safety factors. Going back to the model, if we start putting safety balls on the right side, what is that going to do to the risk level? It's going to push it back to the left. Okay? It's going to help decrease that risk level. Obviously, what you want to do is be thinking ahead of time. What are the potential safety factors that we have at our disposal so that we can manage this situation? Now, is it ever going to go to zero? No, but we can take it down to a level that's acceptable and appropriate, balancing our negative R and our positive R. Safety factors is just like hazard factors have weight. Safety factors also have weight. And big safety factors are going to have a much greater impact on the risk level than small safety factors. So let's take a look at the overall model. We've got hazard factors on the left, and we know that those have mass and push the risk level to the right, and we have safety factors on the right that are going to push the risk level back. So this is a dynamic system. We can take from one side and add to the other side, and that's going to change things. And things change over time. One of the examples that you might present is, I often talk about lightning. So if we have people out in the backcountry and you see a flash of a lightning bolt, and then you hear the thunder 60 seconds later, that's one data point. You see another flash, and you hear the thunder, and it's 70 seconds. That suggests the storm is moving away. And so your risk is going down, but it's probably not increasing. What if the flash to crash is 45 seconds? Now, that storm is moving closer to you. You're in a dynamic situation. The risk level is increasing. Now, it's 30 seconds. You need to be thinking, as the storm is moving, what am I going to do? Where's our location? Are we up on some exposed ridge someplace? Do we need to try to get down fast? If we can't get down, what are our options? And there are a variety of different sort of risk management and safety techniques to deal with in lightning situations. And part of that also depends on the context that you're in. If you're in the backcountry, you've got one set of protocols and procedures that you're going to follow. If you're out on a soccer field someplace, you're probably going to have a protocol. The typical one is the 30-30 rule that says, if it's within 30 seconds, you need to get everybody indoors. You need to get everybody off the field and into some safe location. So that's a good example of how this is a very changeable sort of thing. And as those hazards might actually be increasing, you need to certainly be able to push back by increasing your safety factors. We've sort of taken a look at the full RASM model. And so now we're going to go back to our friend Tom Hanks. And we're going to take a look at Tom Hanks in Castaway. Tom Hanks survives his big wound. He learns how to make fire, survive on the island, and he's been alone on this desert island for 1,500 days. And he decides that he's going to try to get off the island again. Every once in a while, he sees a light out on the horizon, and he knows that someplace out there there's a shipping lane. And if he can get out to that shipping lane, maybe he could get picked up. What we're going to do is watch another scene from the movie. And what I want you to do is just observe what's the same as the first time we watched Tom Hanks and what's different.
You don't have to worry about anything. I'll do all the paddling. You just hang on. I think we did it!
Offstage. After watching the video, what you want to do is help your participants kind of go back to the original hazard list that they made when you watched the first video clip. And so as soon as this clip ends, what you're going to do is kind of go back to that and ask them what's different this time around, and let them brainstorm it. Let them help you change it up on the board or wherever you're looking at it. And then I go back into PowerPoint and kind of walk through what they've talked to me about so that we can kind of see it graphically. Presenting. Now that we've seen what happened to Tom Hanks, let's sort of go back and take a look at what was different this time around. And as you all said, he had a much better raft. Okay? So in fact, he had taken that raft that was a hazard the first time around, and he turned it into a safety ball. Instead of the world's smallest paddle, he had two big oars, big lever arms. This is a subtle thing if you haven't seen the movie, but he did have food and water with him on the raft. He had a full set of supplies with him. Was the coral reef still there? Yes. Were the huge waves still there? Yes. So he can't make those hazard balls go away. Did he have a plan? Absolutely. He waited until the wind changed before he pushed his raft off into the water. Was he indecisive? No. He knew exactly what he was going to be doing. And was there fear and anxiety? Sure, some, but he wasn't in the panic state he was in at the very beginning. And then what about the safety factors? He built a really, really good raft. And he had fantastic paddles and oars now. He had food and water, and he also had a sail as a new piece of equipment. And on the environmental side, he had the wind. The wind was an environmental safety ball. He waited until the wind was blowing out to sea so that it could give him an extra push up and over the waves. He knew he couldn't paddle himself up over a 20-foot wave. He needed the wind's energy. And then he had a plan. He was decisive, he was knowledgeable, and he was determined. Here we have a really good example. We have the exact same environmental hazards in both situations. And Tom Hanks did everything he could to eliminate the hazard factors in his scenario. He added as many safety factors in as he could. And he brought his risk level down. Was his risk level 0? Absolutely not. But he'd been alone on this island for almost 5 years, and he wanted to get back to his family, and he decided that the reward was worth the risk. So those two were at an appropriate balance level for him. This is, again, a really good example, and this is why this is my favorite risk management movie, because it's pretty rare that you can see the sort of exact accident situation play out twice with two totally different consequences. So it's really illustrative of the RASM model in action. This is a good time to sort of go back and brainstorm with your class. What are some of the situations from the heat illness things that we talked about? Offstage. Ask your students to brainstorm, given that 100 degree Fahrenheit, 38 degree C temperature situation, what are some of the equipment-related safety factors, the environmental-related safety factors, and the people-related safety factors that they could put into that situation to help reduce the risk? So brainstorm it, write it up on the board, and that could be really, really useful educational technique. As another part of this sort of sidebar, there are some other examples in the appendices of the PowerPoint that will give you some other options to use for different types of scenarios. You might find it useful to create your own scenario that's most appropriate to your particular context. Presenting. So another thing to think about, again, is that some hazards can't be removed. The hazards themselves are just there and you're stuck with them. So let's take a look at an example that's not just for the backcountry, but can happen in any location. Let's imagine that we have bees as an environmental hazard, and we have somebody who's allergic to bee stings as the people or human factor hazard. And so what we know is if we combine those two things, okay, we're going to push our risk level potentially way high because the severity is potentially life-threatening. Now, there's nothing that we can do to eliminate those hazards. So the only place that we can operate to reduce the risk is on the safety factors. And one of the things that you can do is have epinephrine, an EpiPen, available as a piece of equipment. There are also drugs like Benadryl, antihistamines, that can be an important equipment-related safety thing. And finally, you have to have training. Staff need to be properly trained on how to recognize the signs and symptoms of anaphylaxis, an acute allergic reaction, and how to treat it. Now, what that is going to do is it's going to push the risk level down. It's not changing anything about the probability that somebody might get stung by a bee who's allergic. But it allows you to address the severity level if it does happen. You can counteract the severe consequences of that bee sting and obviously get that person to appropriate medical care as quickly as possible. This is something that can happen on the field just as much as it can in the backcountry. In the situations that I deal with in the backcountry setting, we don't have access to emergency medical care within 5 to 15 minutes. And so we have a potentially life-threatening situation that we may have to deal with miles into the wilderness. And so in those contexts, we need to be prepared for that, recognizing that this is a really, really severe situation. And we need to have all these things, the training and the medications, in place ahead of time in case we have an event like this. And that's part of the prep that you need to do when you're thinking about how you implement the RASM system. We're looking at both the pre-event preparation, recognizing the hazards, and asking how are we going to deal with it if it happens. And then in the middle of the situation, we're able to apply this model as a decision-making criteria for, wow, how serious is this? What are we going to do about it? What do you do if the risk level is still too high? You've removed all the hazard factors that you can. You've added all the safety factors that you can, and you've reassessed the situation, and the risk level is still too high. It's at an unacceptable level for your program operation. So what are the options at that point? Know when to bail out. This is a really, really critical part of risk management, and it's an often overlooked part. I spend time talking to all of our students about the fact that bailing out is an acceptable option. It's a sign of good judgment when you've done the analysis and you've worked it all through and you decide that continuing doesn't make sense, that bailing out is okay. So that's a critical thing that all of your staff need to understand. How have you communicated that to them? What is the expectation that you have, and what's the culture in your organization about the idea that it's okay to bail out? There are so many serious incident events where when you look at one of the proximal causes, it was the human factor hazard of people continuing when they should have known better to turn around and stop. If you're all familiar at all with the book Into Thin Air about the 1996 Everest expedition, that's a great case study in this. The brief story is that they had made a decision back at base camp that on summit day, if they're going up to the top at 3 p.m., no matter where they were going to turn around and head back because they didn't believe that they had enough time to take their clients up to the top and get back down safely. And then at 3 p.m., the lead guide made a decision to let people continue to climb. They did make it to the summit, many of them did, but then they took too long coming back down. They got caught in a storm at night and spent the night out on the summit of Everest, and many people died. And that's a great example of getting to that judgment point and needing to make a decision and needing to have the culture of the organization allow people to understand that it's okay to bail out. So let's take a look at the overall steps of the RASM model as we've talked about it. And I'm going to give it to you as 7 steps, but I also want to just clarify that this is not a sequential model. This is something that's happening sort of simultaneously. You're dealing with different aspects of it. The first key is to identify the hazard factors. What are those potential things that are hazards out there, either equipment, environment, or human factor, or people hazards that could be increasing our risk level? Identify those and then assess what is that risk level right now and how is that risk level for all of the people in our program. Is the risk level acceptable for 9 out of 10, but 1 out of the 10 it's not? Be aware of the risk level for everybody who's operating in this program. Where you can, remove the hazard factors. Get rid of them. Take them out of the equation. Reduce or eliminate them. And so obviously making it a less of a factor is still going to help reduce your risk level. Continue to assess the risk level. After doing whatever you can to mitigate the hazards, what's your risk level now? And add in safety factors. So after removing the hazards, put all the safety factors that you can into the situation and continue to reassess. Where is your risk level now? And if you've done all of those things and you still feel that the risk level is too high, bail out. So again, I want to reiterate that this is not a sequential thing. These things are just happening as you go. And you're going to do different ones at different times. But these are the key elements of implementing the RASM system. And as we said before, these are things that you want to think about before you go in your program as well. And then during, and then we'll also talk about after. So because I work in a university context, I always want to bring this home to how students see this in their daily lives. So thinking about how they transfer this to campus. My program is in an outdoor context, so it's important that the students don't just sort of think about, okay, we're in the woods, and now we're back on campus, so we don't have to worry about this anymore. So I'll ask them, okay, transferring this to campus, what are the most likely situations where you might see some kind of real significant hazard? What happens every weekend? Seeing somebody who's had too much to drink. Or observing someone trying to hook up with somebody else who's drunk or unable to consent. If you see something going wrong and you don't speak up, what are you? And the answer is, you're a human factor hazard. Okay? You're a people hazard. If you see something and you feel like there's a really high risk situation and you walk on by without doing anything, you're also a hazard. This is becoming an active bystander, right? This is bystander intervention. This is see something, say something. And I give the example of you see someone at a party, they're flat out on a couch. You don't know whether that person is asleep because they just pulled an all-nighter or is passed out drunk. You don't know if they're intoxicated, if their blood alcohol level is slowly coming back up, or if it's going down. Are they getting better? Are they getting worse? What should you do? And I tell my students, you need to go over there and shake the person. Hey, are you okay? And if that person pops up, oh, what are you doing? I was asleep. Okay? Then you made a mistake. Big deal. Okay? And what if the person doesn't respond? So then, you start sort of like yelling in their ear. This is basic first aid, right? You're trying to assess their level of consciousness and say, wow, are you okay? Are you okay? Nothing happens. Pinch their earlobe, okay? If nothing happens, now they aren't responding to pain. So they didn't respond to a touch. They didn't respond to verbal stimulus. Now they're not responding to pain. You've got somebody who's unconscious. You don't know why, but they need help. Okay? I talk students through that. Now, the other thing that's really important to talk students through is this isn't easy. I don't want to pretend that going up there and actively intervening is easy. It means stepping out of your comfort zone and moving into that space, okay? When you go into your learning zone, you're moving into your brave space. It takes courage. And don't kid yourself that it's going to be easy, and don't kid them that it's going to be easy. But you need to recognize that you're seeing something and you've got concerns, so your responsibility is to step in and act. These are some of the things that students will see on campus. Now, we've spent a lot of time sort of talking about physical sort of related issues, okay? We've talked about injuries and illness and stuff like that. But it's also important to think about this in a broad context of emotional safety and emotional risk as well. We can't talk about risk management without also talking about diversity and inclusion risks. Physical safety is just one dimension on the risk management spectrum. Emotional safety is equally important, and the hazards can be equally life-threatening. Think about the teens who've committed suicide after bullying. Think about LGBTQ individuals being harassed on campus. Just as much as you have to think about what are the physical safety issues within our context, you also need to talk to your staff about where there are emotional and interpersonal hazards. Assess those risk levels and think about what the necessary guidelines, structures, protocols, and culture need to be in place to reduce the risk level of serious things like that happening. Diversity and inclusion is an equally important part of this equation. Let's take a look at an example of a diversity and inclusion risk situation. So here's a hazing situation. This happened a couple of years ago when a college men's swimming and diving team, they were taking photos of members of the women's swimming and diving varsity team and posting them on a private social media account and ranking the attractiveness of each of those women. It came out that this was happening, and the athletic director decided that based on that behavior that was not representative of what the goals and values of the athletic program were, that the men's swimming and diving season needed to be canceled. You can imagine lots of different sort of hazing incidents. How did the women experience that? What was the loss of trust between these two teams? This isn't a physical injury, but it can be an equally damaging emotional injury to people. Let's sort of think about what are some of the things. How did this thing happen? If we work backwards, what kind of environment existed on this team to allow this behavior? What was the culture? How long had it been present? Presuming that the coaching staff, they didn't know about this, what does it say about the level of communication or trust that exists across that whole group? Why didn't any of the team members say this is wrong and tell the coaches? You've got a whole bunch of series of hazard factors in here that are creating this really toxic environment. If we have that example, this is a really good time to potentially brainstorm with people about, well, what safety balls need to be put in place to prevent something like this from happening again? Things like, how do we productively build a cohesive team spirit that doesn't involve somehow tearing down the other? What about things like a full value contract that everyone in the team agrees to that really talks about values like respect that everybody buys into? What about bystander intervention training so that people sort of understand that when they see something that's wrong, they need to step up and intervene? What kind of healthy challenges teams want to bond around things, but they don't have to bond around negative things that are destructive, particularly to other people. How can we give them team building activities and bonding activities that are healthy? What about cross-team study sessions? So that members of the men's and women teams who are taking the same classes can be studying and working together. And at the same time, what about swift discipline by the coaching staff? So if things are going wrong, there is quick action and stepping in, telling people this behavior is not appropriate. So again, we can imagine lots and lots of different situations where diversity and inclusion, emotional safety is equally important. And so as you're implementing this in your program, you really need to be thinking about that side of things as well. At this point, I think it's really valuable to break into some discussion for your program. So here's some of the key questions that I'm just going to move through, and this would be time to break out into small groups, etc., within your program, or if you're presenting this. What's the typical risk level our program operates, and how much variation is there? How often do our safety factors outweigh our hazard factors, or the other way around? Hazard factors outweigh our safety factors. How often do we end up in a higher risk level on the program? Are we set up to allow protocols to change as we shift into different risk levels? When the risk level is high, do we need to have one set of protocols, and can those protocols relax when the risk is low? How is that dynamic process working? What would we need to do to implement this system in our organization? Then in small group discussions, take an example of a physical risk in your setting and go ahead and analyze the hazard factors, the risk level, and the potential mitigating safety factors. If you've got a real close call or a real accident, preferably ones that are enough in the distance so that it doesn't necessarily involve anybody in your actual audience there, to talk about those. And do the same thing with something that involves emotional risk in your setting, and look at the hazard factors, the risk level, and the potential safety factors. If you want to implement this at the program level, you really need to look at each activity you do and assess the hazard factors, the environment, the equipment, the people, and the safety factors in all of those. And think from the ethical standpoint, what risk level or levels are you comfortable operating with and are appropriate for your program goals? Have a discussion about R- and R+, and make sure that those are at the right kind of balance. They're not always going to be exactly the same. It's fine to have a really low risk and a really high reward, but if it starts to shift the other way, you need to be asking yourself some hard questions about what the ethical standards are and what's appropriate. For the staff level, what are the things that people need to do before an event, before a trip? Assessing the hazard factors, looking at the environment, the equipment, and the people, and prepare a hazard briefing. What do the participants need to know to keep themselves safe? And then you also want to be assessing what safety factors you have to deal with those potential hazards. What protocols, other things. And again, think about environment, equipment, and people. And again, make a decision before this trip goes out. Given this analysis, do we think that the risk level is acceptable? During the trip, now you've got the RASM model to help you manage your trip or your event. Whenever you can, teach the model to participants. That's going to help them with their own self-care. Assess the environmental hazards, the people hazards, the equipment, look at the increasing risk level, the potential for accidents, and follow through with the sort of 7 steps that we talked about. Treat all the hazards that you can, add the safety factors, reassess the risk level, and if it's still too high, then it's time to bail out. And make sure people understand that bailing out is okay. Sometimes bailing out can be just stopping where you are, setting up a tent, getting everybody inside and getting them warm, and figuring out what you're going to do next. So you don't have to keep hiking in the middle of a storm. That's a perfectly acceptable decision. And make sure people feel empowered to make that decision. Not that they have to go on because that's what the trip plan says. After the trip, again, it's really important to get data back. Getting incident and near-miss reports, and staff need to review those, need to sort of understand what's happening, particularly around those close calls, and then think about what does that mean for program changes? What protocols might we need to implement or change? What about training? What about resources? All those things are really critical. We're seeing that we're using this model before the trip leaves, during and after the trip, in order to sort of assess how we can reduce our overall risk in the future. And then when you're analyzing an accident, it's really, really useful. This is a really important technique to sort of gather information. And so one of the things that you can do is, again, take an accident or a near miss, again, preferably something that sort of happened far enough in the past, work through them. There are also lots of situations of real-life accidents that have happened elsewhere where you can use them as case studies and, go through them. Depending on your context, there's all sorts of different examples. Aquatics, climbing wall, field sports, heat, ice hockey. I mean, you can come up with all sorts of things. And there are lots of great historical case studies. I will sometimes talk about the Challenger disaster when the space shuttle blew up. And if you're not familiar with that, go to Wikipedia and read it. But you can clearly see, there was an immense congressional report on that afterwards. And you can clearly identify equipment-related hazards, environmental hazards, and human factor hazards that all combined to create the setting that led up to the failure of the O-ring in the fuel tank that caused the explosion on liftoff. This can be used in lots of different settings to analyze things. And having people sort of practice on something that really happened is a great way for them to learn the model and really sort of feel comfortable implementing it. So let's look at some sort of take-home action steps. And we've sort of talked about some of these already in the discussion, but these are key things that we want people to think about. Really, for each programming activity you do, brainstorm a list of hazards in the three major categories. Think about brainstorm a list of the safety factors designed to mitigate those hazards. And think about how you balance the hazard factors and the safety factors and determine the range of risk levels you think you'll be operating in. And based on your program, decide whether the risk level is acceptable. And obviously, things happen. There may be things that happen that put you way into a risk level you had never anticipated. You can't predict everything. But based on the history of your program and history of other programs like yours, you should be able to kind of get a pretty good sense of the terrain that you're operating in and take appropriate steps to deal with that terrain. And hopefully, people using this model, when they're in that situation that's totally unexpected, this will be a tool for them to help make good decisions, good judgments. If the risk level is not acceptable, you want to figure out how you're going to modify it. And then again, have your students or your staff, whatever context you're working in, think about how this applies wherever they are. So it's not just, okay, I'm in this setting, now I can forget it. This is something that you want people to sort of walk around with all the time. Airline pilots talk about situational awareness. They're just like always kind of paying attention to stuff. They're always gathering data. They're always interpreting that data as it comes in, and they're making decisions. It's not like you turn it off. It's just something that you want to have. Always be on and be ready for. Final thoughts. The biggest mistake about a mistake is not learning from it. So one of the things I want people to always think about is why it's important to go back and look at the close calls and the actual accidents that have happened in your program. There are lessons to be learned from that. And again, I want to be frank and honest. It's not always easy to dive back in and look at those mistakes, particularly if it's been something really serious that's happened. Maybe it's useful to get someone from the outside to come in as a risk management consultant and help you think about that. But if you have had some situations that have been really risky, it's your responsibility to figure out what can we do to reduce that risk. And if you say, you know what, there isn't anything you can do, then you should be asking yourself the honest question of, should we still be doing this activity? It's not always easy, but it's really critical. All of the materials from this workshop are up on www.outdoored.com. There's a NERSA version of this from what I gave at the NERSA conference, or if you search for RASM, that you'll find it. And there are a variety of other pieces up there. There's also, in the PowerPoint, a bunch of appendices I mentioned, a bunch of other stuff, other examples, and some sample case studies where you can present a situation, you can have people analyze it, and then there's some answers there. So there's a variety of other resources available in the PowerPoint. And the other resource is IncidentAnalytix. That's a cloud-based software product for gathering your incident and close call data, tracking it, and doing real-time analytics. So that's designed to really help you identify where some of these risk areas are and to think about how you can properly intervene. Thanks very much for joining me today for the webinar. I hope this is a useful tool for you and your program, and that it's something that you can use to create a better risk management situation for all of your operations. Thanks very much for joining me today.